So this is our engineering prototype, a paddle I've been using for about 6 months. This has taken daily abuse. I took it on the Cape Cod Bay Challenge. So this went 36 miles across Cape Cod. A bunch of other people paddled it, loved it. Let's talk first about the shaft. Shaft is pre-preg carbon fiber, very light. The shaft is tapered. It starts at about 1.25 inches at the paddle end, and it's about 1 inch at the handle end. Nice taper. You can hear it's got a texture to it, so it's nice to grip. It's quite a bit smaller than normal shafts because of the taper, and that makes it really easy to grip, to hold. It doesn't slide in your hand. And with the extended handle that I'll tell you about later, we can accommodate paddlers up to 7 feet. This is where all the work gets done. This is a very, very complex blade. You look at most paddles and you'll see the back side of the paddle is flat. It's a featureless flat surface, and usually with a frog coming down into it. Our paddle is curved on the back side. So it curves, it arches across the width of the paddle, and it's also curved across the back. So, and what that does, besides look pretty, is and be very smooth in this area to help distribute the stresses better, is it makes the edges rigid. So flutter on a paddle comes from the tip of the paddle being able to vibrate vertically. Stiffness resists that. So this curve coming to the tip it's like an arch of a bridge. It makes this a lot stiffer along the edges here, and likewise across the back. It also, in the surf, this is magic. I mean, it's really, this paddle feels so good when you're doing cutbacks. You're leaning back into your paddle with a flat blade, reversed, leaning back into the paddle. It jiggles around some. This is like butter. It stays where you put it, and when you want to move it, it just slides just clean and slick. So here's the business side. This is the working surface. It's got a little bit of dihedral. Most paddles do. Dihedral controls wobble, but it does so at a price. The more dihedral you have, it directs water across the paddle, but it also lets the water escape across the paddle faster, and so it makes the catch weaker. So our dihedral is a little different from most folks in several ways. One is it's not a sharp edge. It's got some curve right in here. We find that mitigates some of that energy loss, some of that grab loss. And then our dihedral starts off pretty extreme at the shaft end. As you move down the paddle, it flattens out very quickly, but you can also perhaps see concavity in that. Our blade is concave on both sides of the dihedral, and then as you move down the paddle, you can see it curves up. It's got a little flip to the end. The whole paddle is actually curved across its length. So this is kind of the power area of the paddle. When you're reaching and you're putting that paddle in, start to pull, doesn't bleed any water, gives you a good catch, and gives you great power right from the very beginning. The last aspect of this blade is the offset. Most stand-up paddles are offset, usually about 10 degrees. This blade starts off being offset about 10 degrees, but then the curve of the paddle reduces that offset, so it's really more like 6 to 8 degrees. There's two purposes to the offset. One is something we call caster. So that tends to stabilize the paddle, just like a caster on a shopping cart. It doesn't prevent wobble, it doesn't prevent the quick little wobble, but it keeps the paddle from hunting, from moving side to side. And if you've ever flipped your paddle over this way and pulled it, you've felt that tendency for the paddle to just hunt. The other thing that offset is for, and this is truly a beginner benefit, when you're pulling the paddle through the water, and you bring it back past your feet and you want to recover it out of the water, if you didn't have any offset, if the paddle wasn't tilted forward, then you'd be shoveling more water out as you pull the paddle up out of the water. Well, you're not supposed to be pulling it past your feet anyway. And then when the paddle is going into the water, this curve and these little concavities here, this concave section channels the air out of the blade. So when you're pushing this paddle into the water, there's no air gets trapped behind the back of the blade. So let's talk about some other different aspects. Because of this structural difference, we don't need to use epoxy to glue these paddles together. If you're using a frog type of connection, you need to use strong glue in here. As far as I know, all the manufacturers ship these paddles with the blade already glued onto the shaft with a permanent glue that you're really not supposed to be able to get apart. Our paddle, we don't need to add any additional strength in here. It's strong enough as it is. You can actually take this thing out and paddle it without any glue at all. But we glue it together with hot glue to heat up the section of the paddle a bit, and then you can just take this paddle apart. This paddle has a warranty the same as everyone else's. It's warranted for manufacturing defects. But if you slam it in a car door or you loan it to your idiot brother-in-law who tries to use it to pry open paint cans or something and breaks it, then all you're out is the component. So if you've broken your shaft, you need a new shaft. If you've broken your blade, you need a new blade, but you don't need a whole new paddle. The other thing you can do is you can change the length anytime you want to. If you've, with most paddles, manufacturers require that you use 5-minute epoxy to glue the handle on. We don't. You can just take it apart, recut it. Likewise, because this paddle is a great surf paddle, but it's also the same kind of weight as the most elite and expensive race paddle, you can use the same paddle for surfing and racing. You can cut it to your surf length and then just use your extended handle to either push it in all the way for surfing or with the spacer for racing. We're making the blades in 3 sizes. There's an 8-inch, an 8.5-inch, and a 9-inch. They're going to be in a little bit short supply. These paddles are made with aluminum molds, and they're expensive molds to make. They're very precise, and they're made in a heat press, and so it's not a fast process. So they're probably going to be in somewhat short supply for a long period of time to come. The one other thing I would mention is I have really bad shoulders, although there's a lot of other folks out there that do, and so I'm always concerned about the effect of a paddle on my shoulder. This is a very stiff shaft, very stiff paddle. You would think that this would be hard on your shoulders, but because there's no wobble, that dead feeling that people are talking about, it's very easy on your arms and shoulders. So if you've got shoulder problems, you try this paddle, you finish a 5-hour paddle and you realize your shoulders don't hurt, or they don't hurt any worse than all the rest of your body. So that's been a pretty remarkable thing. It's been a very interesting process. We've really gotten a benefit from doing all this measurement, and we built a lot better product than I thought we were going to be able to. And I'm really proud of it and excited to be able to share it with you. So thanks for your time.